from the technical panel, Next Gen Technologies, Safety and Security Implications. The panellists are Dr. Nigel Tracey, Vice President, RTA Solutions at ETAS Germany. Dr. Eckhardt Holz, Technical Director, Product Development, Medini at Ansys Germany. Mr. R. Ramakrishna, Senior Director, Site Engineering Lead, Life Care Solutions at ARC GE Healthcare. Mr. Bill Sinclair, Director, US Operations at LDRA, USA. And our moderator, Mr. Shinto Joseph, Director, Southeast Asia Operations at LDRA, India.
Hello, friends. First of all, I know we all invite you to this wonderful session. And in fact, we have people from across the globe. More than that, this session, we should thank our panelists. They were logged in from, odd timings from different parts of the world. We have people from US, Germany, UK, and from India. I thank Ian for setting the stage because this session is just a continuation of what he spoke. You remember the time, we all started our studies. I remember, go back to 1990. I was told those days, 99% of the processors used to go to PC world. Let's see what has happened over a period. Today, the picture is totally different. You see hardly any processors going to the PC world. Everybody is behind the embedded world. That's a drastic shift in the last 30 years. What led to that shift? We should see that part. Very interesting. When I was completing my engineering, I saw the world talking about embedded systems. What was driving that shift? It was people were looking for efficiency. How do I make my systems efficient? Now, how do I bring in efficiency? By putting some intelligence into the system. That's where the computing power started getting into areas which people were never thought about it. Now, towards the late 90s, you see connectivity picking up. The concept of global village, mobile community, mobility, all those things started picking up that time. So from wired connectivity, you move to the wireless connectivity. You saw an explosion on tech world starting from 2000 onwards. You remember the Iridium networks, all those stories. Now, what is new here today? From that era, today we are in a different environment. People are talking about, so complex devices where I would say at a time when we were talking about in 90s or even early 2000, we were talking about single processor, Moore's laws. But today, nobody talks about that. People are gone beyond that. They're talking about multi-core. They're talking about increased hardware complexity, increased number of lines of software code running on your devices. What does it mean? It also brings in its own challenges for developers, designers, developers, testers, certification agencies, and as well as for regulators. On the other side, we also see, people demanding incremental requirement for functionality requirement for devices. Could be cars, it could be medical devices. How do I bring it? As a designer, I will put additional technologies, algorithms on the top of these devices. Concept like edge computing. It started in a small way. Today, edge device is no more a single processor. It does multiple things. It has got AI, ML, whole lot of algorithms running behind that edge processor. So sensor world is evolving and complex technologies. Some of them are cut across all the domains. Like, we have the AI, ML, 3D printing, cut across all the domains, people are using it. But some are very specific to certain industries. So our people, the panelists are going to talk very specific technologies used are popular in those respective domains. So with this background, we have set the stage for today's panel. And my job is, to get the best out of these 4 panelists. They are unique. They each one is unique. There's no duplication in the panelists. So that's the best part. And this is the flow of the program. We have time up to another, say, 1:28, 1:30 is our lunch break. We will sharply conclude at 1:28 Indian time. 50% of the time I'm very sure that we should keep it for taking questions from the audience, because this is a live interactive session. I mean, all of you are here to ask questions, participate. So my request is, please start parking your questions. To whom you are asking this question, please mention. If not, I will look at the expertise of the background of the speaker and then allocate. This is the order. After my initial introduction is over, now we will move to each speaker. They will get 4 to 5 minutes. After that, I'm going to ask one question. In the meantime, please keep parking your questions to those individual speakers. We'll start off with Eckhardt, today's session. Eckhardt, it's yours.
Thank you, Shinto. Yes, so, and everybody, of course, also very welcome to this panel for the ESSS conference, and I'm very happy to see such good events taking place in India. Yes, my background, so what's my background? Coming actually from the area of automotive functional safety, we, with our company, do support since long time now our customers in introducing any kind of methodologies and techniques in order to achieve functional safety in automotive applications according to the ISO standard ISO 26262. What we discovered now in the recent years is that there's more and more new things coming up to our customers, and that's mainly due to the increase in functionality within the cars, the increased application of computer and software controlled system inside the car, and of course also the rise of autonomous mobility concepts, which drives quite a large number of additional standards onto the developers in the automotive domain. And as Ian already mentioned in his initial talk, standard-driven approach is a quite significant approach here. So we have standards now in automotive domain already for functional safety. We have standards here available for cybersecurity, which is in fact an upcoming standard under development. And there's even much more standards coming up, like safety of intended functions. There are new upcoming regulations concerning cybersecurity from Work Package 29 of UNECE. So there's a lot of things coming up in the automotive domain, which has to be handled. What we observe is that sometimes now customers are still a little bit stuck in all these different work. So we discover there may be silos. One person is working on cybersecurity, the other person is working on functional safety, third one is working on SOTIF and product function, product safety. And what we discover is that there's quite often still an unneeded double work concerning the development. So people add safety mechanisms to their systems to observe the correct behavior of the microcontroller and all the electronics, and of course also of the software. They add on top of that one also cybersecurity mechanisms, which again are adding to the complexity of the system. And finally, of course, there's still maybe mechanisms which observe the behavior under all the usage conditions, which observe the behavior of AI algorithms and so on. As a result, quite often, software gets even more complex. That's not a nice idea. We have embedded software, but of course, complex software with separate things for cybersecurity, for functional safety, for product safety, and so on, should not be overly complex. So our strategy and what we also discuss is that people in these different domains should cooperate, should work together, and make jointly initial requirement specification, jointly make an initial architecture which ensures safety, security for the systems to be developed in an early stage, and then proceed, of course, with the appropriate software development, with the appropriate configuration of the system to get that running in the automotive domain. Okay, thank you, Shinto.
Thank you, Eckhardt. I think you set the stage correctly, putting the background, the connectivity between safety and security. Now we will move to another area, a man who specializes on automotive security. Nigel, your views, please.
So thanks, Shinto, and thanks, Eckhardt. I think that set the scene very well. I think automotive is a very interesting area in the field of safety and security. So in automotive, there's a number of very unique challenges. So of course, in automotive, you have very high production volumes. That means if you've got safety problems, if you've got security problems, chances are, because of the very high production volumes, you're likely to face these in the field. They're likely, even if it's a rare chance of a safety failure, the production volumes means that probability is still going to affect a significant number of people. Additionally, the automotive industry is now building one of the most complex software systems on the planet. Most modern cars, especially if you look at maybe modern high-end cars, have 120 million lines of code spread across maybe 80 to 100 computers on a network inside the car. You know, that's an order of complexity that we don't face in too many other industries. But of course, because of the high production volume, you've got huge pressure pushing down the costs to try and put in safety and security without adding overhead and without increasing the bill of materials for the system that you're building. These things combine to make it a very challenging environment. One last thing, especially from the security point of view, that's become very relevant more recently, is the increasing demand on safety, especially in automotive, can only be there if you have a security root of trust. Because the main thing about certifying and arguing safety is that you know that the system that's in the field and in operation is the system that you certified. And automotive's a very open space. We manufacture cars, then we put them on the road, give them to public. There's very little then security measures about or measures to control access to those vehicles. Therefore, the security mechanisms to make sure that the systems are not tampered with, are not adjusted, are not changed, become very critical. So topics like detecting change, looking for intrusion detection become very important. Otherwise, you can't reason about safety anymore if you don't have that root of trust in security. So with this, the topics of safety and security really come very tightly together in automotive. The last point I'd like to mention is I think safety and security are inevitably a life cycle topic. And that's a big, big challenge for automotive, because the classical way of building systems in the automotive industry is lots of development effort right up to the point of production. And as soon as the vehicle goes into production, the project team is disbanded and moves on to their next job, the next project, the next generation. But actually, safety and security have to be managed across the lifetime of the operation of that vehicle, like we see in the nuclear industry, the rail industry, the aerospace industry. And this is creating some new challenges for the automotive industry, for continuous update of software, for continuous development and monitoring in the field. And some of the upcoming regulations, like the UNECE requirement for cybersecurity over the lifetime of the vehicle, are really going to have a big impact here, changing not only how we technically do things, but how the industry is structured for projects that the teams have to be around to keep the software up to date, to monitor its safety and security across its life cycle. So there's lots of interesting challenges coming up for automotive.
Good, thank you, Eckhardt. I will come back to you. I missed asking you one question, which I kept it ready. Nigel, I have one question, because you spoke about, the security regulatory areas. You see a lot of platforms nowadays coming in automotive area. People talk about platform-based development. How do you see standards playing a role when people start adopting platforms?
So standards are really critical here. They help break down the problem and give you some foundations to build on. So in the automotive industry, there's been a very successful initiative over the last 15 or so years with the AUTOSAR standardization that was mentioned in the introduction that we just heard before. And here, the AUTOSAR standard has gradually progressed to address topics like safety, putting in features like end-to-end communication protection, and more recently, security. So building in security functionality for the communication stack, building in ways to connect hardware-accelerated security so that you can add in security authentication and encryption without adding significant overheads. And here, by standardizing those things, it allows everyone to exploit them without having to invent the wheel again, because the main job of the car is not to run a safe and secure platform software. It's to run a braking system or an engine management system or a window lifter. And what standards allow people to do is to use trusted mechanisms, industry best practice, to build and focus on their innovation, their functionality, their content. So standards, I believe, are really important here, especially to help give the mechanisms for safety and security. Of course, it doesn't solve the whole problem. What's really important is you have to use those capabilities coming from the standard in the right way, to combine them in intelligent manners to solve the specific problems and the environment in which you're putting your system in. So it provides a set of ingredients, but you still have to put the ingredients together in the right way to get a good cake at the end. So it helps a lot, but it's definitely not the whole problem solved, simply because of platform standards like AutoSAR. But I think it's a necessary foundation.
Yeah, I agree with you, because I don't know whether you've seen last month, Germany for the first time started talking about, bringing insurance laws, discussions on insurance laws for autonomous vehicles. This will trigger much more serious discussions, because if you want to insure something, you should have some certification. If you want to certify something, you should have a regulator in picture. If you want to do both, you need to have standards. Without that, this is not going to happen. So thanks for putting your viewpoint. Now we will move towards Ramakrishna. He's a healthcare man. He comes from the medical device world. Ramakrishna, your viewpoint from your medical background.
Hey, first of all, I think good morning. I think very early good morning to Bill, and kind of good morning and good afternoon to India, Asian teams, and also Germany. Hey, Shinto, thank you for inviting me for this panelist. Yeah, for me, I think what just now the Eckhardt and Nigel said, all are basically applied to medical industry also. When I say medical, I particularly talk about the diagnostic and therapeutic. I don't talk about pharma, because I'm from GE Healthcare, primarily in diagnostic and therapeutic. That's what we heavily, play. And yeah, the medical industry traditionally, right, it is basically, it is unconnected to a public network. And if you look, traditionally healthcare industry not connected here very much. But right now, I think the technology evolution, right, the healthcare is moving away from diagnosing at a facility versus, you can diagnose the patient across anywhere where they are. And that's what providing accessibility to the healthcare system for, remotest possibility of the world. That's one thing. As we grow in the direction, it becomes very, very challenging and interesting to provide how you provide a safe way of patient data, and also make sure it's secure and it is no privacy is compromised. That's one of the important things, right? And second thing is, if you look from the clinician's clinical perspective, also everybody want to offer variety of actually advanced diagnosis tools and all those stuff. And it means you are going to handle a lot of data. And if you look most of this, right, a patient point of view, a clinician's point of view, or a clinic point of view, everywhere data is going to move across a lot. And this is basically healthcare patient data, right? And security is one of the most important things. And second thing is, and security of the device, and how actually your device is secured, because the moment you're trying to connect to a network, you are basically is exposing your devices. Most of them are embedded devices, because as Shinto mentioned, you want performance, you want ability to do actually what you want to do without compromising anything. And also you want lower footprint and lower cost too when you give this kind of devices. So that means the device, while designing itself, I think you have to, ensure the safety methodologies has been implemented. When I say safety, for device safety and security, you have to look for every layer. It is not just a layer you look at the outside, being most of embedded devices, you look from the hardware and the software layer, the OS layer, everywhere you have to look into. So healthcare is also trying to catch up the way I think automotive industry has been developing, I think the platforms, and also trying to leverage the embedded UI and UX, everything effectively. So healthcare in a way trying to see from the standards and regulatory wise, how do you go, as close as aviation, and also in terms of platformization and leverage what automotive industry has been doing it, right? So that's the kind of healthcare industry right now going. And on top of that, another third direction maybe standards and regulatory, right? Every country want to come with their own regulatory and standards in the data handling. So that's also becomes quite important, and how your devices or how your systems are coding, right, or upgrades or software patching or comply to this a specific regulatory standards of a specific country or a specific region is most important. I feel everything is evolving right now. We're all learning and also trying to help our customers to do the best.
Thanks, Ramakrishna. Well, the interesting part is, with lockdown and COVID, healthcare is one industry which everybody talks. I mean, the sad part is, countries spend much more money for buying weapons than, buying medical devices or healthcare or treating people. That's a sad part in the whole world. But silently, you can see, a digital transformation happening in the entire medical domain. I would say the so-called digital healthcare. I just have one question to you, because this is a massive disruption, right? And how do you see the whole ecosystem evolving? Normally, we need to give some time, but now, all of a sudden, you have a new ecosystem getting ready. How do you see that?
Yeah, I think, to be honest, I think we're also learning and also addressing. For example, I come from a business called Life Care Solutions, and where, I am primarily also involved design development of ventilators, my team across the globe. And ventilators has been in the, I think, limelight last, I would say 18 months across the globe. And second thing is the patient monitors. And third thing is ECG devices. And all 3 or 4 of these are the a tool the doctors want to monitor a patient. Unfortunately, you cannot go to near to the patient every time. So now the remote diagnosis, one thing is number of devices, which is basically a production challenge. And we have taken a lot of help from automotive sector. That's one. And second challenge is going to be, once you build this devices, number of more devices, now suddenly you have to develop a feature that helps the clinicians and remotely diagnose and remotely analyze what's happening and all those stuff. And that area, I would say, is basically evolving, right? You may see a lot of teleconsultations are happening right now heavily. That's a good sign of the digital transformation. But telemedicine is evolving in my view, right? Because not all the healthcare devices today are capable of doing all kinds of telemedicine things. So I think primary challenge with this last 18 months, the people faced about the availability of devices, but even the devices are available, they are not readily capable to do any kind of teleconsultation or telemedicine point of view. And that area definitely, as Shinto, is increasing. It definitely is going to increase further. And that means, I think you need to put the data out in an unsecured public internet or network. So that's also other challenge we need to see how we need to gear up with that.
Thanks for your viewpoint. In fact, you would have seen with autonomous systems or even safety practices, automotive industry picked up a lot from the aerospace. Now you're saying, medical industry is picking up certain things from the automotive industry. That's a good observation. From here, now we'll move to someone who is always interested in flying. And Bill Sinclair, he is more from the aerospace side. Bill, your views, please.
All right. Thank you. It's an honor to join this distinguished panel and share with you some of my ideas about the aerospace industry, and in particular, the avionics domain is where we work primarily. And so things such as fly-by-wire, multi-core platforms, sensor-based controls in general, this has led to a proliferation of software and programmable electronic hardware capabilities in the aircraft. So with these increased capabilities, multiplicity of software products and distributed processing have been managed with something called integrated modular avionics, which has scaled from large transport aircraft, such as your 737s, to smaller aircraft, but complex aircraft such as fighter jets. So this IMA technology, we can elaborate on that in a minute here. Also, the issue of limited reuse and portability of this software is addressed by something called the Future Airborne Combat Environment, or FACE. And this is a consortium of private industry suppliers and DoD development groups. So thinking about the IMA in a little more detail, this performs a coordination and synchronization of disparate systems using bus architectures such as AirInc 653. It conforms with an FAA standard, DO 297. And IMA is a shared set of flexible, reusable, interoperable resources of electronic hardware and software. And when integrated to form a platform to host applications performing various aircraft functions. So this is an area that LCS, LDRA Certification Services, which I am the director of, we provide advanced support and training in DO 297. And then the FACE consortium really has introduced something quite novel in any industry that I've seen, in that it's a lightweight process to verify conformance to a FACE technical standard requirements. So this is an actual test that you submit your, what we call units of conformance, to FACE defined APIs. So the FACE conformance testing does not require execution of the software. It's conformance testing as a link test. And then it adds this very sophisticated layer of middleware to allow supplier to adapt to these APIs. So with this, we now have a way to determine the compatibility and the reusability of these many units of conformance that you can develop and individually supply and submit to a function such as something LDRA supports is a verification authority. And we independently verify and validate these units of conformance for our customers. So that kind of is where we're dealing with the most advanced challenges in the aviation space, particularly again in avionics. Shinto?
Yeah, thank you, Bill. One interesting observation from your viewpoint also. You spoke about FACE. When I went through it, I found, it is another AutoSAR. So, see people learning from experiences from another industry, how automotive industry evolved over a period on AutoSAR. Now aerospace is trying to evolve on the FACE environment, which will be really good for the whole industry to come up so that, the interoperability, reusable component, all those issues could be addressed. Bill, I have an interesting question for you. We hear a lot about 3D printed parts in defense, in automotive, so many areas. People are talking 3D printing. Do you see a scenario in aerospace, somewhere in the base depot, someone is printing a part and putting it in an aircraft and flying, and how the regulator would see this?
Actually, this is something that has been happening. It's under extensive development right now. This, in terms of the regulation, it's basically limited to experimental aircraft and to very small scale applications. So what the FAA has done, and the ESSS, has tried to allow this industry to develop, and they recognize the expertise of the people developing this 3D printing and this what they call the additive manufacturing is really the term that they use. It's additive manufacturing. and they're allowing the suppliers to the industry to manage this and self-certify, if you will, these manufactured parts. Again, these are used in very limited applications, but it's still a multi-billion-dollar market already in the aerospace industry. So we see this as an area for significant growth in the very near term.
Hopefully, before me and you retire, we might be able to see a 3D printer, aircraft from our garage.
And there's also something we have in our industry called tool qualification, and that would be the mother of all tool qualifications to qualify a 3D printer. Yes.
Okay, so thank you, Bill. Now, I had a question left, which I had supposed to ask to Eckhardt. Eckhardt, actually, people are talking a lot. Actually, you set the context with the connectivity between safety and security. But I see a lot of shortcomings in the current approaches. Can you just elaborate the current shortcomings in the industry towards safety and security practices?
Yes, so one major point what we still observe is, at least in the automotive industry, that the activities for functional safety and also for cybersecurity are usually started at some late point. So what we discover is that already quite some significant development work has been done. There are initial boards already available. There's the first versions of the software already being developed. And then they got started to look into issues about functional safety, what risk could be taking place if there's a bug in the software, what could happen if some electronic part is broken, and also what can happen, what kind of threats could be done to attack the system and do some kind of intrusion in your system and so on. And what is the result is that usually, because there's already quite some development work put into this one, that a lot of redesign has to be done. And especially in the automotive domain, people were not so much used to having something like external intrusion into the system, which is a very big topic for cybersecurity. So they still rely, oh yes, we have our protocols, everything is working fine, we have the following encryption here, and it's used for 10 years already or even longer, and we just trust it. And suddenly they are exposed, oh well, there may be completely different threats from the outside, which they never had in mind when they already started to make the architecture and make up all the embedded software and so on. And then it's a significant effort, of course, later on, either just adding shell by shell around your system to capture once more another security threat and so on. So an initial consideration of the risks of the system without even looking at the details of the implementation is usually very, very helpful, because it will save you time and will help to avoid the risk of duplicated work and so on. And another point is also about the good behavior of the system in all conditions. It's about product safety. And here again, we observe that this is pushed very far to the end of the development process, just done by verification validation. So you drive around with your car and check, is my camera really recognizing everything? Is my radar really not getting disturbed and so on? And it's sometimes like running in the dark and trying to find something. And usually, again, here, a guided approach and very early step in the development process is helpful to identify very, very early. Okay, if there's a heavy rain and even snow and ice, then maybe this may impact not only my cameras, but it may also impact my radar. And suddenly I'm lost with my autonomous car, because at least two of my systems which help me to get information about my environment may already be impaired. And this is usually, of course, a thing which could be discovered much, much earlier, and not just doing a VNV and maybe even doing a verification validation, just VNV for the camera system, then do a VNV for the radar system. And each of these are referring to the other one. Oh, there's redundancy. If I'm not working, there's still the other system. And suddenly you discover, well, there's no redundancy, because there may be a really common mode, common causes related to all these aspects. So I vote strongly always for the topic to start as early as possible in the development process, even if everybody knows the resources in automotive industries are very limited and the schedules are very tight, start early with all your safety and security activities in order to get the system development costs at the end at the right level. And one final step, I think also Ian mentioned this in his opening speech, you will not stop to work on it. What we discover now is that there is, from these product by product releases, there's a much more agile approach in the industry. You have this software over the air update. So there is continuous add-on of features. And that also means your safety and security work will not stop. So that's an important point. Issues from the field have to be fed back. And you have to do, of course, all the safety security analysis for all your updates, which you activate over the air or which you upload over the air. So that's challenges which are still there. And maybe one additional point, because we have also mentioned about aerospace and some other points. I was once at a conference and I heard a nice talk about the guys from the rocket industry, because they mentioned, okay, what's there in rocket industry? You have highly skilled engineers which develop safe and secure systems, which are operated and maintained by very, very well trained and skilled people in a very closed and safe area, because nobody is just walking in there. Nobody's just grabbing a rocket and going somewhere. And automotive industry, again, you have very, very sophisticated and, well, potentially dangerous systems, which are operated by your average John Doe with maybe very limited skills in an environment where nobody is protected. And that's what the automotive engineers always should keep in mind. They cannot rely that everybody's using the vehicle is really doing maintenance, is doing a very well-trained operation, and also the environment. There's a lot of places where a risk can really result in heavy injuries or damage to people. Okay.
Thank you. I think you brought in a different perspective. It is basically, whether you want to follow a proactive approach or a reactive approach, or better late than never, because it all links to the cultural perspective. Because in India, some part of Southeast Asia, I'm seeing a reactive approach. Okay, we'll see it later. Initially, just discard many of these things, and later on, when they approach a certification agency like a TUV, UL, then they say, no, we cannot certify this. Go back, rework, and by the time you rework, the product is already out. I mean, there's already a competition product already there in the market. They lose in terms of time to market. So with this, actually, we have a lot of questions pouring in. Guys, we will turn towards the audience. We will try to take as many questions as possible. So please start posting your questions. We'll start off with the security question again to Nigel. How this is from Ashwin. How legacy automotive platforms can be upgraded to advanced security features, meeting the current standard needs?
So I think that's a good question, and especially security has come into automotive in an environment that's really not well set up for security. So things like the in-vehicle networking, the CAN networking technology, which is pervasive in automotive, is completely built as a technology that doesn't fit for security at all. I mean, it's a multicast network where all nodes on the network receive the signal at the same time. There's no authentication of who sends a signal, just that it's received by all of the ECUs. So the automotive industry didn't have the luxury of reinventing the wheel and giving up on these legacy systems. In fact, it indeed, just like the question is hinting at, had to focus on how do we address this for the legacy systems? How can we layer in an approach that can work in the existing environments and add an adequate level of security? And some of this legacy constraint created big challenges. I mean, CAN data payload is 8 bytes long. If you want to do security, you often talk about signatures that are maybe 256 bits or 4096 bits long. Doesn't fit in a payload of a CAN frame, and certainly there's not the bandwidth in the car. So actually, the whole approach to safety and security in the automotive industry has had to take care of these legacy systems. So while the software platforms may have moved forwards and AutoSAR may continually step forwards and add these things, it's really supporting the legacy environment from a hardware perspective and not changing that. So advanced safety and security mechanisms are exactly coming into the legacy system. So in CAN networking, the security approach of AUTOSAR is to add message authentication codes. And these can only be of limited length, otherwise you're going to use too much bandwidth in the car. But it's finding that balance between performance and adequate security. And exactly supporting that legacy framework has been, I would say, one of the biggest challenges to introduce these things. Because you simply can't move to a new technology. Would have all been easy if we could just throw away CAN bus and move to some new design from the ground up, secure network, or something with significantly more bandwidth. But that's simply not realistic in the automotive industry. So exactly those legacy challenges have been addressed, have been solved, and normally by moving the software platform forwards and finding acceptable compromise solutions. And generally that's worked pretty well. Now, what you see at the moment in the automotive industry is also a transition to new electronic architectures that are introducing a new kind of system, a vehicle computer, a much more powerful, much more like a server class 64-bit CPU type device. And in these environments, there's a lot more potential to invent things from the ground up to be secure and to build security in from first principles. But for what we see in the classical control systems, which will remain even in these new architectures, then legacy systems have exactly had to be taken account. So we don't see a transition away from CAN bus to something new for security. We see a smart, intelligent way of thinking how to layer security onto the legacy systems, balancing that need for performance, cost, and security. Yeah, legacy systems are handled, I would say, largely by changes to the software platform.
Hopefully, some of these cars will get phased out, and new cars will come, and people are moving towards EV. There, I think people are taking care of these issues because a new design, at least you have a control on from the beginning. Ramakrishna, I have a question from a guy, Amrit Roy. What are the regulatory challenges for medical software in India? Would you like to comment?
Yeah, in general, I think the healthcare industry, when I say healthcare, again, I limit to diagnostic and therapeutic. And that industry, from device perspective, medical device industry is not yet regulated in India. But I think slowly they started. The Bureau of Standards of India, BSI, is trying to BIS standards. They're trying to introduce a few standards starting last year, but not in a scale of like FDA in US and European Union standards like CE marking or the like CFDA or Japan FDA. Those kinds of not in place yet in India, but they are coming. That's one. In general, the software standards, what we follow is FDA, and FDA is also nowadays updating the cybersecurity standards. And that's what cybersecurity point of view standards are evolving in healthcare industry, but the guidelines how to do it and all those stuff, depending upon kind of attacks your device can face. That's the currently status of standards.
Good. Actually, globally, if you look at medical device regulation, people are talking about a piece of software as a medical device. That's the way the definition is going. And in India, we have a long way to go. I fully agree with you. Even currently, what we have is more of self-certification, and that is also more from a QMS perspective, quality perspective, a risk-based approach. Hopefully, we will see evolving, which is very important for the industry to mature. Again, one more question to you. Again, linked to medical. Suppose, what are the challenges in customizing a automotive or aerospace standards to medical?
I think I just saw the question. So I think we need a deeper look there, because if I go systematic software development process, as Nigel explained just now, and previously somebody else here, if you look, I think the medical industry, I mean, I'm not sure how many times you upgrade. Are you on the fly, you send a patch to automotive car? But the medical industry, I think expectations are of ransomware. ransomware really pulled down a lot of hospitals in the US. And that is basically, really hit a lot of people who are in the hospital. That means, I mean, you have to really have a software development approach in such a way that it could be patchable at whatever level it is going to be. It may be at a minute level, OS level, operating system level, or it may be the application layer level, right? And so we need to see how the automotive industry does in terms of entire software development process. I know most of the people follow agile practices, but in terms of the customer point of view, because here the clinicians and clinics and workflow point of view, we should see what are the possible similarities. Then definitely yes, I think we see an opportunity in terms of leveraging some of those standards. But definitely the medical industry, I think as we software standards are very, very standardized, very much standardized in terms of device that stays in a hospital or a clinic. But when it comes to the connected network and those kinds of areas, it's still evolving.
Good. In fact, if you look at all these standards, fundamentally they are all risk driven. Maybe the safety integrity levels somebody might say 4, 5, medical might say it's only 3, but the whole principles remains the same. The people need to look at from a safety angle, and maybe interpretation, some terminologies might vary here and there. Anyone who played with industrial systems on 61508 should be able to easily move to 62304, that kind of standards. Anyway, in the medical track, we have more papers on the same subject. I suggest you guys don't miss those papers. Bill, I have an interesting question. Yeah.
One more point I just want to add, like Nigel also mentioned, the life cycle. I mean, like car people use more than 5 to 7 years. I think the medical devices are also utilized. And diagnostic devices can go up to 10 years. So the life cycle, right, with the evolution of technology, evolution of the platforms, how do you basically leave the hooks for future upgrades, right? The next 10 to 12 years is very, very important. So you also need to look how the standards are put for the case of automotive. And in the case of healthcare, we do have standards, but I think you need to see how you could really help the customers to be able to use those devices safely and securely next 10 years.
Good. That's an interesting observation. And Bill, I have a question. How to balance between safety and security in systems? Because this, I would request you to come in from a context. Today, a lot of systems, especially in defense and aerospace, complex systems people are making. But then I'm also the opinion that, these systems may not work when we really wanted to use it. Make it so complex, and sometimes, it is not secure. Someone might hack into your device, and system may not work when you really want it. But at the same time, you want the system to be more capable, blah, blah, blah. So where do you strike the balance between safety and security and even functionality?
That's a very interesting question. It is in the aerospace industry, security has become to play a pronounced role in the development process in the last 3 to 5 years. And this is one because the aircraft system and the ground controls are inherently isolated and tightly controlled. So the likelihood of a security event happening that's outside the realm of what's predicted and what's expected by the standards is actually fairly low again. So the major transition now is to bring the concept of security into the design process, and not as an additive step taken at the end of the development process, but it's integral from the very core design concept that you have to build the security process in with it. So now there's several new standards that address security in aerospace and avionics, and there's been very good progress in this area. There are things that do enhance security, the multi-core technology that is very prevalent in the avionics space, because it allows processing to occur at a very localized level, at an individual processor level. And so this allows you to assign design assurance levels specifically to a core, to a particular core, and to manage that, and that greatly reduces security risk, but it also can greatly reduce the validation and verification effort in what is otherwise an enormously complex system. So we see things. We see the evolution of this, and it's been a rapid evolution, as I say, in the last 5-6 years. But we're seeing it as being woven into the overall development process and the systems development concept that you get from standards like ARP 4754A, which deals with aircraft systems development overall.
Thanks, Bill. But my worry is, after learning all these things, I might think about flying again. I might think about using a medical device. I might even think about, getting into a new car. So sometimes it is better, we don't know too much about it. It at least gives you that kind of confidence level. Okay, we'll go to an interesting question. Eckhardt, but probably you might take it up. What is your opinion towards safety of machine learning and AI algorithm? I know Sarif is trying to address this, but I do see following issues: how to address long tail data security, training data, weights. When we say AI/ML algorithms are beating human ability in a car, would you like to comment? Sorry, you're muted. You're muted.
I'm sorry. Yes, so beating human ability in a car. So that's, of course, you would have to define some kind of a measure for all the abilities here. But let me get started here. Safety of machine learning and AI. Yes, this is in general a big topic which has to be handled. And there's, in fact, actually two things. One is the training phase for the AI, where they really have to learn to recognize pictures and so on. And that is a place where you have to achieve a high level on security on the data itself. So it's more or less management of data, secure management of data. So nobody's capable to do some intrusions into the images and videos which are used for security, hiding some maybe not human visible information in those ones, and bringing the training onto a wrong path. So that's one side. You have to make a good management, cyber management for the data which are really used for the training. Second point is, of course, this, you have to achieve a high level of variation later on if you check the learning. That's the other side. You have it on the car, and that's what I mentioned also, that you have the VNV sometimes at the end where you have to train, okay, does the system really recognize everything outside of the car? Does it recognize the planned behavior of the car, short-term planning, long-term planning, and so on? So that's where you have to bring a lot of VNV measures. There's unfortunately not really much. You can do quite some automation. You don't have to drive everything, so you can also use simulation systems, appropriate software to check the expected behavior versus the existing behavior. And the third point is, a good strategy is still not to have the autonomous or the AI algorithm just being the only one who determines. Usually it's good to have something still deterministic inside the car, which is wrapping it. So, and there is a couple of deterministic rules which you usually would always agree to implement. And that's, for instance, your car should always have a minimum distance from any other car in front of you and behind of you, and even left and right to you. So that's a very deterministic rule, for instance. You should also always have some rules about the vehicle speed. So what should be the maximum speed compared to other moving objects surrounding you? It's again a deterministic rule. And such a wrapper around your AI helps at the end prevent that the AI will do a decision which can be a deadly decision. So even if the AI says, okay, let's accelerate, the deterministic shell around it would still say, okay, if I accelerate, then the speed difference with the vehicle in front of me is too small, and also the distance to the vehicle in front of me is too small. And then you have this wrapper around it. And because this is deterministic, you can do much, much more sophisticated checking for the safety and security of this one compared to checking the AI algorithm, because you never really 100% know why it learned something. Okay.
Thank you. I have a question from Rajesh Verma to Nigel. What are the certifications or training for an engineer required to comply for validating safety integrated levels involved in the process of enhancing safety and security in automotive products?
So I think first and foremost, safety is about good engineering, and especially software safety is about good software engineering. One of the things that can be very dangerous, or dangerous is probably the wrong word, but that can mislead engineering effort with the standards that exist, is the goal is not to tick the boxes of the standards. So the standards make a lot of recommendations on certain processes to use, certain techniques to use at different safety integrity levels. It's a pretty consistent pattern across all safety standards for software in different industries. What I've seen happen very often, however, is that becomes the goal. The goal is to get MCDC coverage of the code. I've even seen this taken to the extreme of, well, the goal is to get MCDC testing of the code, so we're writing all the inputs to achieve that, and nobody bothered to check the outputs. So no one knows whether the test passed or not. We just know that we can figure out how to drive the software down all of the different conditions. That's exactly one of the approaches that must not be followed for safety. And what's important when taking training or learning about the standards is to realize the standards there are to support you do a good job to build a safe and secure system. And they're providing recommendations and techniques that are believed that they would help you think into the corners and test into the corners of the system to make sure that you're covering all aspects, maybe some that would get missed otherwise if you're going too fast. But what's very important is the goal is not to get MCDC testing. The goal is to test all of the functional behavior of the different conditions through your software are performing correctly. So training around the safety standards exists. There's lots of training courses in the automotive industry on ISO 26262, on SOTIF. But I think it's very important when taking those trainings to realize they're there to support good software engineering. And the goal is not to fulfill the standard. The goal is to build a safe system, and the standard is meant to be there to support you in doing that. So I think you can never separate training around the safety standards to also training to be a good software engineer, a good developer, to take time to think into the corner cases and the rare conditions. Nothing can replace this. That's a very, very important part of doing a good job of safety development. And therefore, I would say you need to get a balance between engineering training and safety training. And of course, there are certain techniques. There's things like FMEA or fault tree analysis. And here, training definitely helps to learn how to use those techniques, how to apply them to your system, and how to benefit from them the most. And training here really definitely helps significantly because they're techniques that you might not have come across in your normal computer science or electrical engineering training. But I always think you have to be very careful that the process dictated or recommended by the standard never should become the goal. It's always a means to the goal, and the goal is always a safe and secure final system. And I see that way too often, that actually ticking the boxes of the process becomes the goal. And that's the thing that should be avoided. And you have to be careful with the training that it doesn't lead you more to that path.
Very interesting observation. In fact, I have seen a lot of people saying, I got that certificate, this certificate. But I asked this question, really follow these things? No, that was for my certification. So
someone once told me that good safety engineering and good safety processes are about slowing smart people down enough that they have enough time to think into the corners. And that's the job of the standard, is just to slow people a little bit so they have the time to think it through. And the process is therefore not so important so long as it gives time for smart people to think. And there's no replacement for the smart software engineers thinking into the corners.
Good, thank you. We have another question. He has kept it open. This is from Krishna Kumaran. How to address security issues when we use open source software in real-time systems? Who would like to take it up?
I could take that.
Issue? Yeah, Nigel, maybe.
Yeah,
I could
maybe.
take it.
Oh, sorry, go on then.
Oh, sorry. I just wanted, because what Nigel and Bill said, right? I think it's a purpose. His purpose is very important in safety and security. It should be part of the design process, what Bill mentioned. And the purpose and keeping the safety and security as a part of design cycle at early stage is what actually gets us an automotive product or a healthcare product is safe and secure enough for the customers to use it. And I just want to summarize, I think, a couple of your points. That's exactly what we also say. It's not about using the standard, it's about understanding it, the purpose of it, and how do you make sure the purpose is utilized in developing a good product. And coming to the open source, right? Yeah, I mean, the healthcare industry is heavily going towards the open source. I mean, if you see from Microsoft to open source Linux mode, everybody wants to try to use it, right? And open source gives the advantages. At the same time, it also gives associated problem solves what it comes with, right? And yeah, I mean, that's where one has to, while designing the, while taking the open source as the path, one should basically evaluate those things at the earliest. And it's exactly what we have gone through, a few years back, and we use a lot of open source tools. So, but what we need to know is what exactly framework you have to use it while using this open source. At what level, and you have to really need to have threat boundaries defined at the early stage itself. If you don't define the threat boundaries and threat modeling, if you don't do it when you use open source softwares, open source codes, it's very difficult at a point of time, because those are the entry points for anybody to hack you or make your system vulnerable to all kind of attacks. And that's the first step. I think if anybody want to use open source, you need to understand number one. Number two, I think you need to understand, you need to have the system in place, thereby you have a continuous watch on those open sources, whether there is any vulnerabilities across the these open source softwares are going on, thereby you can actually react much faster. Rather than reactive step, you should do proactive monitoring of this open source and openwares, thereby you could provide good systems going forward. There's a couple of things we normally follow and pretty much successful, but at the end of the day, it's about what is the purpose of doing it. And the open source, if you want to use it, you need to really have a threat modeling and threat boundary, and doing a design FMEA at the early stage would definitely help you to mitigate the risks which you're going to see going forward.
Thank you. We are almost coming to the end. We will take one or two more questions as max possible. There's one for Bill. Bill, how automated tool results can be trusted? A tool qualification is the method for anything or any other methodologies.
Can tools be trusted using due to tool qualification? Is that the question? Yeah, of course. That's essential to to defining a safe and secure system, is qualifying the tools that you use both for development and for verification. And so there is a key tenet in the standard DO 178C that the software tool that replaces the judgment of an engineer needs to be qualified. So any engineering judgment that is ordinarily performed by an independent engineer that's assumed by a tool, then that has to be qualified. That's the criteria that gets applied to tool qualification. So just in the last 7-8 years, you've seen a real solidification of the practice of tool qualification across the aerospace industry. It was in prior days, it was basically optional, and you had to make an individual case with your DER, your designated engineering representative, to determine what tools you would actually need to qualify, which were critical. Now it's standardized. There's a new standard that came out, DO 330, that deals strictly with software tool qualification and all the steps that you have to follow to get there. And we work extensively in the automotive industry and supporting tool qualification in that industry as well. There's a lot of commonality between the industries, among the industry, and how this is done. But in terms of a core principle to understand how you assure safety and security in these systems, you have to be dealing with qualified tools.
Thank you, Bill.
Yes.
Maybe,
And maybe
if somebody would like to know more about it. We are running short of time. So if somebody would like to more about it, you guys could reach us in LDRA booth. Like, people would be able to help you to more about how the tool qualification. We do that as a service itself. Bill and team is into that business itself, in fact. So maybe a quick 30 seconds, if conclusion from each one of you. Maybe you would like to add before we wind up. Starting with Eckhardt.
Yes, so thank you very much. I think this was a very great discussion. It showed once more that these topics may be overlapping really among the different domains, aerospace, automotive, medical, and there's a lot of other domains. And I think one point we always have, we should learn from each other, because each domain is having some very advanced topics where they are really good, and there are other topics where they may trail behind others. And it's always good to learn from each other and to get a very safe system developed at the end, like Nigel also mentioned. That's the task.
Yeah, Nigel, please.
So I can only echo what Eckhardt said. I think that's very important, is to learn from best practice from other areas. I think also what's really good in this event especially is to bring safety and security together, because there's a lot of different terminology used, but actually from a systems engineering perspective, there's a lot of overlap, there's a lot of similarity. I think if the terminology could come closer together, you could bring two specialisms together to drive each other forwards here, because the task of solving safety and solving security challenges in your systems engineering are very similar ultimately. Yep.
In other way, it's the two sides of the same coin. Without addressing security, you and your systems are not safe. Ramakrishna, please.
Yeah, I just second to what Eckhardt and Nigel said, and I just want to add one more point there is, and this actually should start early stage of product development. I think it cannot be like ticking the box. It should be part of your systems engineering and early stage of product development.
Thank you, Bill.
And I want to focus on some of the points that were made by Nigel in particular, but we want to emphasize the integration of safety and security in systems development, and then how that flowed down to the individual software and electronic hardware development. And having this comprehensive view of systems and safety is really the key to making a complete, rigorous approach to systems development in the future.
Thanks, Bill. Proactive systems approach. That's the way forward approach. Irrespective of whichever technologies comes and goes, this outlook, having a proactive approach, more holistic systems engineering as a subject, I think we all should promote a lot. And I think that is the missing element in many industries. So I take this opportunity once again to thank each one of you, the panelists particularly. They've taken a lot of pain, preparations. Really appreciate it. Thank you, guys.
Thank you,
Thank
Shinto.
you. Thank you.